Hey everyone, it's Miss Mac here with another video. And this time our video will be a review of functions. So in this video, we will cover a lot of different topics on functions. We will be able to identify from a graph, table, set of ordered pairs, or a mapping diagram if something represents a function. We will be able to find the domain and range of a non-continuous function, and we will be able to evaluate a function for given domain values in order to find the range. So let's get started. First, we need to know what is a function. And a function is just a relationship between two variables, usually x and y, where each input has exactly one output. So you might be thinking, what do we mean by a relationship between two variables? So imagine this situation for a minute. Let's say that you were trying to figure out if there was a relationship between the number of followers someone has on TikTok and the amount of money that they could make per post. In this case, your amount of followers is going to be your independent variable. That's a thing that is changing. And your dependent variable, our Y value, is going to be how much money those people make per post. Well, in order to be able to determine if this is a function, we would need to see that each input has only one output that is assigned to it. So each x value has only one y value that gets to go with that x value. So let's take a look at some data and try to decide if this relationship from our TikTok example is a function. Okay, so let's look at the information that was provided for us for this example. We can see that we have a table and a graph, and both this table and this graph represent the same information, which is our X values are all of the followers that these TikTok stars have in millions, and our Y values are the money per post that these TikTokers make. So we can see on the table, for example, that if a TikTok star has 500,000 or zero point 0.5 followers, we can expect that they would make $200 per post. So we said in order to decide if this relationship is a function, we need to see that each input has only one output. And so the way that we'll do this is we will look at our x values and we will try to notice if any of our x values repeat. And if one of our x values repeats, then the question we have to ask ourselves is that x value partnered or paired with a different y value? And if it's paired with the same y value, then that's okay. That means our relationship is still a function. But if we have an x value that is paired with a different y value, if we have an x value that repeats and is paired with a different y value, then our relationship would not be a function. So take a moment to look at this table and see if you notice any x values that repeat. Hopefully you noticed that we have the x value 1.4 that repeats. So the question we need to ask ourselves is 1.4 paired with more than one output? And when I look at my table, I notice that 1.4 repeats, but both times it is paired with the same output. So it's paired with $4,500 or $450. So this table represents a function because each of our inputs has only one output. Next, we could look at our graph, and this graph is showing us the exact information. And if we were just to look at this graph, we could still determine whether or not this relationship is a function. And the way that we would do this is we would look to see if any of our points are stacked right on top of each other. If they're stacked right on top of each other, then this relationship is not a function. But I notice here that none of my points are stacked on top of each other, which means that this graph would pass the vertical line test. And that tells us that this relationship is a function. Go ahead and take a moment to look at this graph. Does this graph represent a function? Is your screen time a function of your age? Hopefully you were able to see that there is in fact one x value that repeats and has a different output. So if we look at the x value 16, we notice that it is paired with two y values. One time it appears to be paired with about 5.5, and the other time it appears to be paired with 6. So we would say that this is not a function because each x value is not only paired with one y value. There is one x value that repeats and has a different y value. Okay, so our next learning target talks about domain and range. Domain refers to all of the x values in a function. And some other things that we say for domain are that they are the inputs or the independent variable. Our range is all of the y values of a function. And some other words we use for that are outputs or dependent variable. So let's go back to our TikTok example. Our domain is all of the X values or all of the followers on TikTok in millions. And when we write domain of a non-continuous function, we list our function, or our domain rather, from least to greatest. And if there are any domain values that repeat, we only write those numbers once. Finally, you'll notice that our domain is written in brackets. And the brackets are just those fancy parentheses that you see on either side of our set of numbers. And those brackets are what we use to represent a set of something. And in this case, we're talking about a set of x values. Go ahead and think for yourself for a moment. What would the range of this function look like if I were to write it as a set? Okay, so here's our range. Our range is all of our y values written from least to greatest in brackets. And we noticed that there were a couple y value, or there was two y values that repeated, the y value 2 and the y value 4.5. And so we wrote each of those values only once so that we were not repeating any values in our set notation. Our third learning target is that we want to evaluate a function for some domain values and find the range. So we need to know, what does it mean to evaluate a function? And this is something that you all already practiced recently. We said to evaluate means to find the value of something. So when we evaluate a function, we will take an input and we will find the value of that function for our output, or we will find the output. So let's look at what this looks like on a graph. This tends to be the most challenging example of one we want to evaluate. It says evaluate the function below for f of 1. So that means I want to find the value of this function when my input is 1. So I will look on the x-axis for 1, and here I find it. And then I'll go over to the y-axis and see what was my output when my input was 1. And I noticed that when I follow that point over to the y-axis, my output when my input was 1 was 4. So f of 1 for this function is 4. It's just the number 4. Sometimes we are asked to evaluate a function when we are given an equation. And in this case, we have our best friend Desmos that's really helpful for us. So this example says, evaluate the function below for f of -1. That means I'm going to take -1 and input it anywhere I see x in this function. So I will replace x with -1 3 times in this function. And this is something that you practice doing by hand, but we can also use our Desmos calculator to help us out. So if I type this function into Desmos, exactly how I see it, f of x is equal to 2x squared plus 8x minus 2. And then in the second box, put f of -1. Desmos will calculate or evaluate this function for me. And what it said was that when my input was -1, my output was -8. So the range of this function was -8 when the domain was -1. All right, everyone, I hope that was helpful. If you still have questions, go ahead and watch this video again. And don't forget to subscribe to our YouTube channel and like this video. Thanks.